Lesson 5.5, Solving Equations by Graphing. You should be on page 263. In this lesson, you will learn how to solve linear equations by graphing. You will learn how to solve absolute value equations by graphing, and you will use linear equations to solve real-life problems. I'd like to review before we get to the graphing on how to solve a linear equation such as this by just work. We learned this in chapter 1 of the textbook. It's easy. Check on each side. Can I simplify? Can I add opposite x and 1? Or could I subtract 2x and 5? And the answer is no. Next step, always get all your variables on one side of the problem. So I don't want 2x on the right. I'll take it away from each side. And now you should have an easy two-step problem to solve. I can take away 1. Remember, maybe I should do this. Good review for final exam. Onion, right? Take away 1, divide by -3, x is 2, and you can see that's matching what the book says. Okay? We're going to learn how to solve this also now by graphing. And that's an easy process. To solve a linear equation by graphing, it's simple. You take each side of the equation, and I color-coded this, you make each side equal to y, and you graph both of those equations. Okay? So here would be a good example of that. Let's do this problem that we just did showing work. Let's do it together. So let me color-code this. I have that. Turn on this layer here. Here we go. We have this, and we have this. Let's write two equations. The one in orange would be y equals -x plus 1, and the one in green would be y equals 2x minus 5. Well, this is easy. The slope in this problem is -1, and the y-intercept is 1. So let's graph that. Here's my y-intercept of 1, and my slope of -1, which is down 1 over 1, down 1 over 1, and so on. For this equation, let me do this in blue, my slope is 2, and my y-intercept is -5. So let's go to -5, that's here, and my slope is 2, up 2 over 1, up 2 over 1. And when I draw those two lines I'm meeting at this point is the point 2, -1. That means x equals 2, just like my work in the previous slide said. My answer, x equals 2, matches my graph where x equals 2. Okay? I would like you to go ahead and try graphing these two problems to solve them. Pause the video and do that. Okay, so we're back, and the first equation, I made the left side equal to y, which you see right here, and I made the right side equal to y, which you see right here. So, first equation, the y-intercept is -3, which is here, and the slope is 1/2, up 1 over 2, and I drew a line. My second equation has a y-intercept. You notice there's nothing here. That means the y-intercept is 0, and the slope is 2. That means up 2 over 1, up 2 over 1. I drew that line. You notice, excuse me, these two lines meet at the point -2, -4, so x is -2. It's always good to check that answer. If I put -2 in here, I get -1 minus -1 minus 3, which equals -4. And if I put -2 in here, 2 times -2 equals -4. Those match, so it's got to be -2. Let's go to the other problem, number 2. I'm going to do this one in blue on the same paper here. I wrote my two equations, y equals 9x minus 4 and y equals -3x plus 2. My y-intercept's -4, which is here, and my slope is 9. That's up 9 over 1, up 9 over 1. I drew a line. And then my second equation, my y-intercept is 2, that's here, and my slope is negative 3, down 3 over 1, down 3 over 1, and I drew a line. Now this one, it looks like the answer is a half. It looks like it's over a half. So that's kind of, is it exactly? Let's check it. That's how I can make sure. If I plug a half in here, 9 times half minus 4, that would equal a half. And if I plug a half in right here, I get negative 3 times half, which is negative 1 1/2. And if I add 2, I also get a half. So yeah, it's got to be half. That's the correct response. Okay, so you can solve an equation with variables on each side by graphing it. That gets us into solving absolute value equations. This was something that some of us struggled with in Chapter 1. It's easy. We got to remember that when we solve absolute value equations, we should expect 2 solutions. So let's review how we did that by showing work before we get to the graphing. Okay, so here's an absolute value equation. I'm going to highlight it. It's right here. And what you do is you just write the problem down without absolute values and you solve it. So I can't simplify. I got to get all the variables on one side, which is why I'm taking away the 2x. And then from here, you're just treating this like an onion. We have to take away the 1 and divide by the negative 1. X equals 5. There's one of my answers agreeing with the book. Now, here was the part that some of us screwed up on in Chapter 1. We have to write a second equation. Absolute values typically have 2 answers. Now, the left side, you don't change anything, but the right side, you need the opposite. That's why I have the minus in front with parentheses. I need the opposite of what that is. So what I need to do here is I have to distribute this negative 1 through, and now I solve as normal. Get all the x's on one side, and now I can onion the problem from here, take away 1 and divide by 3, and you see that matches what the book has. That's how we would solve this by showing work. But you notice in the book, they want us to solve it by graphing. So how do we do that? Well, it's easy. We do the same thing we did before. So let me go to my new screen. Here's the problem. And I'm going to write 2 equations. I have y equals x plus 1 and y equals 2x minus 4. I'm going to graph them both. Here's the line for y equals x plus 1. Do you notice? Y-intercept 1, slope 1. My second equation has a y-intercept of negative 4 and a slope of 2. That's why I'm going up 2 over 1. And x equals 5. This is the point 5, 6, so x is 5. That's one solution to the problem, and you notice it matches what I had here. Okay, now let's get my other solution. Remember, I'm going to write 2 equations. Do you remember that second part of the problem, let me highlight it, I got to write the opposite of that. So my first equation will still be y equals x plus 1, but when I distribute the negative 1 through, my second equation will be y equals negative 2x plus 4. Okay, let me graph those. Now, the first equation matches what I had here, so I'm just drawing that line again. It's y-intercept 1, slope 1. My second equation, the y-intercept is a 4, and the slope, down 2 over 1, down 2 over 1. Let me draw that line. And it looks like these meet at the point 1, 2. So if it's at 1, 2, x is 1, and that matches, that matches what I had here with my work. So you can also solve absolute value problems by graphing. To finish up, we can solve real-life problems. Now, the book has you graph it. I personally wouldn't graph these. I think the graphing is a bigger headache. It's something you'd need to know how to do, but we could solve this by just showing our work. Okay? Your family needs to rent a car for a week while on vacation. Company A charges $3.25 per mile plus a flat fee of $125 per week. Company B charges $3 per mile plus a flat fee of $150 a week. Now I want you to notice something. We have a rate of change here. Okay? You're going for a vacation for a week. you got to pay this much a mile. That's the slope. You got to pay that much a mile. That's a slope. And then they charge a flat fee of $125. That's your y-intercept. They charge a flat fee of $150. That's your y-intercept. So you can easily write two equations. How many miles of travel are the total cost at both companies? So here are my two equations. For company A, the cost would equal 325x plus 125. There's my slope and y-intercept. And company B, cost would equal 3x plus 150. Well, cost equals cost. These are the same. We want to know, when are these the same? So you notice what the book did. They just made both of these equations equal to each other. Now, they're doing it by graphing. I think that's a bigger pain than just writing the problem down. Okay, let's simplify. I can't. Let's get all my variables on one side. I wouldn't graph this. I'd just solve it like this. So 0.25x plus 125 equals 150. I can take away 125 from each side. So 0.25x would equal 25. And I got to divide each side by 0.25. And if I'm doing my mental math right, x should be 100. Okay? And as you see, that's what they have here. So if you wanted to graph both of these, you could. For me personally, I always think graphing takes longer. It's a bigger headache. I like to use pencil paper algebra to solve these versus graphing. Now, if you want to graph it, you can. I think I'm going to pause the video there. If you have questions, make sure you ask in class.